Hi, in this video, I'd like to look at how we can use the formula for compound interest to find the value of P. P is our principal amount. It is the amount a person invests in an account or the amount a person takes out as a loan. A is our accumulated amount, I is the rate of interest, and N is the duration. To make it easier for us, let's make P the subject of the formula. To get P by itself, all we have to do is to divide both sides by the bracket with the exponent of N. So on the left, we can say A over the bracket 1 plus I to an exponent of N. On the right, we have P multiplied by the bracket 1 plus I with an exponent of N all over the bracket 1 plus I to an exponent of N. Now on the left, we have A over 1 plus I to an exponent of N. On the right, the brackets will cancel out and we're left with P. We have now made P the subject of the formula. Let's put P on the left-hand side. Let's clear this up and put the formula up here. To find P, we start by adding 1 and I. Then we find the value of the bracket to the exponent of N. And finally, we divide A by the denominator of the fraction. Let's look at some examples. Taryn takes out a loan and agrees to repay $400,000 in 3 years. The bank charges interest at 24% per annum compounded annually. How much was Taryn's original loan? Here we are looking for P. So let's find our A, I, and N values. Taryn agrees to repay the bank $400,000. So we can say A is equal to 400,000. She repays the bank over a duration of 3 years. So N is equal to 3. The bank charges an interest rate of 24%. So to find I, we say 24 over 100 and we get 0.24. Now that we have these values, we can put them into the formula. So we say P is equal to A, 400,000, all over the bracket 1 plus the value of I, 0.24, to the power of N, which is 3. Now we have 400,000, all over 1 plus 0.24, which gives us 1.24 to the power of 3. Now we can take our calculators. We say 1.24 to the power of 3, find its answer, and then we divide 400,000 by that, and we get $209,974.90. Remember to always round your answers to 2 decimal places. Let's do another example. Isla's parents gave her $30,000 for her 21st birthday. Her parents said they had invested a sum of money on her 10th birthday that had grown at 13.5% per annum compound interest for 11 years. How much did Isla's parents invest? P is our principal amount. It is the amount you start with at the beginning of an investment. And this is the amount we need to find in this question. So let's find our A, I, and N values. Isla's parents, after their investment, had $30,000. Our A value. So you can say A is equal to 30,000. The bank offered them an interest rate of 13.5%. So to find I, we say 13,5 over 100, and we get 0,135. They invested for 11 years. That's the duration. So N is equal to 11. Now that we have these values, let's put them into the formula. We can say P is equal to A, 30,000, all over the bracket of 1 plus I, 0,135, close the bracket, to an exponent of 11. Now we have 30,000 all over 1 plus 0,135, which becomes 1,135 to the power of 11. Now we can take 30,000 and divide it by 1,135 to the power of 11, and we get $7,450.18. This is the amount that Isla's parents invested. Let's do one more example. In 5 years, Gemma wants to buy a house for $32,000. The bank offers her an interest rate of 15% per annum compounded annually. How much must Gemma invest? Again, we are looking for the principal amount, so we need to solve for P. Let's find our A, I, and N values. Gemma wants to invest for 5 years. That's the duration. So N is equal to 5. She wants to have an amount of 32,000. So B, the accumulated amount. So A is equal to 32,000. The bank offers her an interest rate of 15%. So to find I, we say 15 over 100, and we get 0,15. Now that we have these values, we can put them into the formula. So we say P is equal to A, 32,000, all over the bracket 1 plus the value of I, 0,15, to the value of N, which is 5. Now we have 32,000 all over 1 plus 0,15, which is 1,15, and in bracket with an exponent of 5. Finally, we can divide 32,000 by 1,15 to the power of 5, and we get an answer of $15,909.66, rounded off to 2 decimal places. And we have now completed this question.